It says determine where the given function is increasing, decreasing, where its graph is concave up, concave down. Find the relative extrema, that's your maximums and minimums, inflection points, sketch the graph. So here's the sketch. What do we know? We know he has a minimum at 0. Which means that he is decreasing till he gets to 0 and then increasing after 0. So the first derivative should tell me that I've got a critical number at 0, decreasing into it, increasing out of it, or a min. So that's what the first derivative should tell me. Second derivative is going to be far more complicated, needless to say. And that's where I'm looking at concavity. And I notice that he is concave down. He changes somewhere. He is now concave up. That means in here somewhere is an inflection point. Then he changes back to concave down. That means someplace in here is an inflection point. When I do the second derivative, I'm going to have a change in concavity in 2 places. One on either side of 0. One negative, one positive. So here we go. Like I said, first derivative, easy peasy. Second derivative, not so much. So here we go. F prime of x. This is not that second derivative is hard. It just gets messy. F prime of x. Bring the denominator up times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. In order to get the second derivative, we're going to have to make sure that this sucker's right. So this then becomes 2x cubed plus 6x minus 2x cubed, that's so cute, over x squared plus 3 squared, or just 6x because the x cubes add the 0, that makes our life nice, over x squared plus 3 squared. I first set that equal to 0. The only way that can be 0 is if the numerator is 0. So here's your critical number, x equals 0. We already know that is a what? Minimum, right? So we got the right number coming out of here. The other thing we have to look at is where f prime of x does not exist. And that's where the denominator can't be 0. Or x squared plus 3 can't be 0. Is x squared plus 3 ever 0? I put any number in for x. Squared it is what? Positive or negative? Positive. Positive plus a positive is positive. I never will find an x value that will make that 0. So I only have one critical number. And that critical number is 0. And so I'll pull 1. And we take a look. The denominator is always positive. So if I take 6 times 1 over positive, that's positive. Negative, because it changes as it goes across. That says negative, positive. This is a minimum. By the way, that's why I don't use the second derivative test. First derivative certainly tells me whether or not I've got a maximum or a minimum. That tells me I have a minimum at x equals 0. So increasing from 0 to infinity, decreasing from minus infinity to 0, and I have a min, and they want the do they want the coordinate points? Yep, points. At 0, well, this one's an easy one. F of 0 equals 0 squared over 0 squared plus 3, which is 0 over 3, or 0. So it's 0, 0. And that matches my graph. So this is the information that they're looking for off the first derivative. First derivative, max, min, increasing, decreasing. Like, take a look, 0, 0, that's it. So that certainly matches my graph.